Okay, I think we're ready. So, today we're gonna work on raster plot click again, and we're gonna work on the little Lisp language we developed last stream. Yeah, let's get into it, I think. So, the context is like, I wanna calculate wages in a dynamic way. Most companies will have different ways of calculating this, and I'm just gonna make a DSL for that. That's like the entire backstory. I think I'm actually mostly done with this stuff, but we still need to basically save the programs as well and like make them updatable and do like a little bunch of stuff around it. So like the core ID is already finished. Oh, it's the wrong screen. This one. Excellent. And this is it. Right. So this is like the thing I ended up with, and we need to add one more function, and then we're mostly done with this stuff. I think I wonder what I changed since last time. Let's look at that. I don't know, like, I worked a lot on this, like, I really enjoy doing this. It's crazy. It's like, mostly when I work on raster.click, there's a lot of front-end stuff, and it's just not that interesting to do. But, you know, I do it anyway because it makes me money. Let's see, so Sunday was the last stream. Let's deal with that. I don't know what I did. Let's see the difference. One thing I did, yeah, exactly, I let you quick check. So, we now can fuzz our little Lisp language. And I think this is kind of important because this already detected a couple of problems for me. So yeah, we can fuzz the Lisp language. And we added instances for text, so you can generate random text. So a quick check is basically a fuzzer, right? Like you give it, it's actually kind of clever how it works. Let's actually show that. EDN spec. So I put everything in EDN spec for some. But what you do is you basically make. Let's see, where do you have it? Here. You make like a function that ends on a bool, and then this stuff needs to be this needs to have an instance. Have the instance? Yeah, arbitrary, right? So if you have the instance arbitrary, it can figure it out for you how to make a quick check test out of it, and you can just like you use it in text Haskell, wherever I do that, and you can just use it in property, and it will make like hundreds of tests for you. This thing is actually generating a lot of tests for me. I think the amount of tests I have has like, yeah, like it will just generate 100 tests. You can even modify the count if you want. If you want to generate more, but there should be enough. So yeah, like it just generates tests with like random inputs, right? That's the idea. So it's fuzzing it, and sometimes it fails, and then just like pull out the failing case and make another test for that. So one thing that failed was this, for example. Yeah, but that works really nicely, actually. Okay, cool, that was quick check. So what else did we do? Do I have this? Yeah, we had a quick check. Oh, right. Suppressed an exception in the backend. Right, I think I did it on Monday or something. Make this code even more horrible on the backend, but that's fine. There's not a lot of complexity in the backend, so I'm like fine with code sucking there. I should also move this closer, I think. Cool. So closer. Yeah, so we made this code more horrible, but at least now we can detect if we get some sign error and reply on that appropriately. In most cases it will still be throwing an exception, but now at least the one case where if we entering the slash and the user has been deleted, we no longer throw an exception. That's what I wanted to do. It took a lot of changes actually, quite a few, yeah. So this is the quick check stuff, and oh, we added so many tests. This is just me trying to figure out how that operating stuff worked. And it took me a while to figure out how to implement the fold left implementation correctly to make it behave like closure. It still doesn't completely behave like closure because closure actually does star is 1 for some reason, and I'm just throwing an exception in that case. This is crazy. I don't want to do that. I don't even know why it would be 1, but it does throw an exception on the vision. So why? Who knows? Maybe because it's a monoid or something, and that the empty case is 1, and it can like fill in those empty cases. Maybe it also works for plus like that. Then, yeah, because the empty case for plus is 0. Okay, because like if you do 4 plus 0, it will be still 0, or I mean 4. Like the result will be still 4. And it's like the semigroup law for monoid. If you look at the data. Figured out my issues from last night. Yeah, you slept on it. What were your issues? Like, I didn't watch the entire stream because I fell asleep. It wasn't obvious how to deal with cross-module messages. You can just use the functions, right? Just wrap them into another function. I mean, convert message from one type to the another. Yeah, there's it. That's what I was doing it wrong. The nice thing with Elm is that you only have one way of doing it, so this is like the only true way. So yeah, we also cleaned up apply expression, I guess. Deleted a bunch of redundant code. So this is how Lisp works, by the way. This is how you apply expressions. This is it. This is doing that fold left behavior with variable arguments. I think I can even delete fun. I'm just using variable arguments everywhere at this point. That's pretty cool. This stuff is just helper functions to work with bindings. Because I need to provide initial functions in the language itself to make it all work together. So for example, I'm providing multiplication here by binding it to Haskell values. And we need to pin down the type, otherwise it doesn't know what to do. Like you need to pin down types at some point, and this is what I'm doing here. It can't be generic everywhere, it needs to know what it is. We don't have runtime polymorphism in Haskell, really. We pin down everywhere. So yeah, this is the final one, I added text. So now we need to add if as well. The thing is that types guide you into the style of doing things. Everything is composed on the top level. Hi. Hello, Louis. What's up, man? How is your, what is it? Close your Google. So by the way, subtraction is not closed under the set of positive integers. For all integers, it's closed. Wait, what? Oh, if you just say positive integers, it's not closed. But if you say all integers, it is fine. Oh, okay. So subtraction may be a magma then. Okay, that's... I thought it was all integers, but it's the positive integers, yeah. What a fool I am. So yeah, like subtraction may be a magma then. And maybe also divisible. Like, if you're not associative, you're probably divisible. That's how I read this. The fuck is an inverse semigroup? If you have a semigroup, how do you get there? Maybe the red arrows are not allowed or something? The quasi group is also associative or something? Then you inverse? I don't know. I was like, that can't be right. Yeah, I misread it, okay. Yeah, it's me just starting this stuff in anger. Trying to solve problems. But as it comes to architecture, this kind of thing inevitably leads to large tree-like structures, which makes it for a really large amount of coupling. Oh, for, you mean this stuff, what I'm doing here? Yeah, it actually became unreasonably large for text, because it's basically 2 to the power of types you want to match against. And I wanted to do 6 types for text. I wanted to do car, I wanted to do bool, I wanted to do int, I wanted to do double, I wanted to do text. So that's like 64 things I had to do here, like that. So I did text a bit differently. I essentially did first the one binding and then the second binding, and then said like, okay, you're normal now, okay, you're now text, and then I joined them together. And that like is not 64 bindings like that. We're talking about Elm, okay. Well, I had the same problem with like a lot of bindings. Actually, you can for Elm there is an I remember a guy using like functors to combine Elm modules with each other. There's like the magic read along or something, and he discusses that because you don't really have profunctors in Elm, but you can just add the morphisms to functions, and then you kind of fake the behavior like that. Like you just use higher order functions instead of type classes, right? And then you can make it work. Classic group thing. Cool. Yeah. This is, by the way, how you learn impressive jargon. Studying these images. Classic group Q star is a set of Q. It's a set Q with binary operation star. That is a magma. So this is probably not multiplication, but something else. Obeying the Latin square property. This is definitely not multiplication because it's here. That's probably product. No, it could. I don't know. I'm not sure. This magma. Obeying the Latin square property states that for each A and B in Q, there must exist unique elements X and Y in Q such that both A times X, A and B. So you can like recover that. So you can reconstruct for any element in Q, A and B in Q. It's not if else. It is condition else, which is something else. You're not making more of a sentence like that. I mean, I'm always happy when my code ends up being sentences. Like, these days, no longer the case ever anymore, but I used to be able to do that quite often. And then I stopped caring at some point. Maybe I just got better at reading it or something, I don't know. Around the pairs. But that doesn't work here, right? Yeah. I'm in favor of cont. I'm not sure, actually. It will be much easier to use if, I think. If else. How would you do else though? I thought of just doing if, like if, and then this is like you know, the condition, and then this is the true and this is the false. I think I only need if. Positive 5. Minus 5. Error doesn't get here. 0 error doesn't get here. Positive. Okay. Alright, I use brackets. I thought of just well, like, you know, I have them lined up, right? So I'll get one argument. I can just, like, you know, check if it's true or false, and the other argument I can just, like, return if it's true. The only problem would be, how would I just like stop the execution of more arguments? I don't know how to do that at the moment. Always folding. Yeah, I'll just stick with the closure one. I have closure here, so yeah. So this algorithm is basically a fold left. And through trial and error, I figured out that if the remainder arguments are smaller than 1, I should put it like the remaining, right? You need to parse. Then I just need to return the result, and otherwise we'll keep on going. But if we're gonna do too few parentheses, really, I'm not. Oh, okay. I thought it was a joke. This is not a Lisp if you don't have enough parentheses. I get it. So the issue with cont is that I can't, like, stop this evaluation. I need to keep on going. And I don't really know of a way... Oh, we can return maybe a special kind of failure. Maybe we can, like, make instead of runtime error, we call it, like, runtime events or something, and we can return a trap. And check for the trap. Scheme is also, like, common Lisp. Truth is a Lisp, empty list is false. Wait, what? Okay. I don't know why you told me about all these Lisps. He's making a really simple Lisp in Scheme. They have all a little weird flavor. But my Lisp is not even Turing complete, by the way. I can't define functions, I can't define arguments. The only thing you can do is reduce an expression. You probably want a simple type Lisp. It should be like common Lisp. One is pretty strict. I'm not... The only thing I'm gonna add... Like, okay, I'll show you what I have, right, in this language. So we can query this parameter from the environment. The month work minutes. I'm gonna make it shorter. Week minutes, month minutes. There you go. We can multiply, we can divide, we can do plus, we can do minus, and we can make things into text. What's the difference between booleans and non-booleans for truthiness? Oh, right, I need to figure out truthiness now. Yeah. That's a good point. We'll make probably also a cast function for booleans or something to bool, and then you can make it explicit. Now you can use comparison for that, right? You can just use equality. You can't compare floats then. That would be a pain in the ass. Oh, I need to make float comparison as well then, for sure. Float comparisons. So that would be like an epsilon or something. We do like a range. So yeah. Let's write it down, the to-do items. To-do, make programming world time view. Okay, we're pretty far with this, by the way. So to-do, what do I want to do? I want to add if conditions. Okay, then after doing that, I want to do this, I want to add comparison. And I may wanna maybe add float comparisons as well. So people could define their own environment and then, you know, use that instead. I don't know. I bet tons of people already have implemented Lisp in Haskell. Yeah, you have Look at that. I mean, I think the difference I'm having is that I'm using closure syntax instead of all this stuff. How many Lisp implementations there are out there? Yeah, but it's also like pretty easy to do, right? I've not even worked on this for a week and it's already, you know, basically functional. This is my first time as well. Start time naming convention is for global mutable variables, dynamic scoped variables, etc. Spread this in common list closure and record style guides. Earmuffs. I don't think I'm supporting mutability at all at the moment. I have a pure Lisp here. about that? I can make a Google for this Lisp because it's pure. Yes. That's what I should name it, pure Lisp. I wonder if someone named it like that. And there's already one. Definitely extensible. Pure Farnaband will be like binding comparison. We should behave similar like Scala implicits. Yeah, that's what I mean, right? Like you can, that's what I intend to do. Basically, use the environment, and then if you wanna make like global changes like that, you just make your own little environment and boot up a Lisp deeper. Go one level deeper in your Lisp's change, right? So you get like you can have local inconsistency if you want. Not nice for REPLs. Hold up. Just need to enter that environment. I have no intention of making a REPL. Yeah, basically zero intention. I want to add if. Let's do that. Let's do the simple one then, with just the function, I guess. That's fine. So that would be, if, and then we'll do function. So this will be the condition, I guess. Boom. And then this returns another function. And this is like on true. True. And this returns another function. On false. I guess it's just primap. This will do like evaluation as well, right? This will do like if you have a symbol inside there, it will try to figure out what the fuck it is. Or if it's a list, it will do apply. So yeah, this does all the, figuring out if this symbol is something or not for us. That's my primap. And if I'm using primap, I can, which is maybe as well, huh? We can use on for that. I've learned a lot about. I've like learned a lot from just doing this. It's kind of interesting. I've learned a lot about algebra. I've like picked up fuzzing as well. Not that it was necessary, but it just seemed useful because I have a lot of type juggling going on, and I want to make sure it's right. Primap com, right? And then we just want to figure out, well, are you primap? What do you do? You need to have the environment as well. That's SCD, I believe. You have the environment, and you have your value, and then your value is like maybe, right? Because it can be nil. You can just use maybe false. Maybe on false. And then we'll use bool on false on true. This will be a C. What will you do with that? I think this is about it. Shoot Lispy. There you go. Great naming. But at least now it's grouped under multiplication, so it's less. Oh, this is the wrong one. I put it on the wrong one. It should be here. You too. 0 failures. Okay, excellent. Haskell sum. Describe summing in Lisp. There's that. I have a lot of sum things. Oh, this is all the minus stuff. More multiplication stuff. Oh my god, there's too many tests. And this is that was summing, right? That's the binding stuff. All multiplication stuff. Oh my god. It was a bad idea to just put it under Lisp. But I think this is it. We'll make like one big block out of this. Multiplication. Cool. And then we have summing. And then we have division. I'm gonna move that up higher. There you go. Division. There you go. It's like a lot less well tested than the other stuff. But it's also multiplication. That's because I couldn't do quick check stuff for division, unfortunately. Because I couldn't find the Haskell equivalent of the sum data type. I guess I could have raised my own vault, but I'm not sure if that's why. Oh, I want to go to line 50. Okay, I see. I'm still used to the relative bindings, I guess. But we can just jump to this, I guess. Maybe not. Delete. Oh, it works? I remember now. You can do like 55, 72, delete. That's cool. And then you just put it here. Better. It's a bunch of unused do's. We have division, we have summing, we have multiplication. Is that Lisp structure? Oh, there's a division and summing as well. And the text. We have like another division. Subtraction. That's everything. Okay, excellent. And we can delete this entire. Okay, that's cool. 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 Looking pretty good. By the way, function text is usually called string, I think. Yeah, I know. That's why I wanna make aliases, because I wanna, keep the old names as well, but I wanna, rename stuff as well. So we should add aliases. That's actually a good to-do thing. I think we should do that sooner rather than later. It's like probably after if we tested the shit out of this, then we'll do that. Add aliases. And then like one thing I want to do is alias string, alias text to string. Like I want to make them both available like that. But just explaining to someone that it's called string instead of text is gonna be painful. But I want to keep the old support. Oh, we'll throw an error. It'll say unexpected type or something. So this thing, this is like, first we'll try out this thing if it's an int. Oh, then we fail. Okay, we go to this thing, right? And then we fail again. Oh, we go to this thing. Oh, look, it works. Okay, we can go ahead. But that's basically how I'm like handling the fact that I don't know about types. I'm just trying out the first one, second one, third one. In case of if we don't try out anything, so we will just return a failure. Yeah, with prime map. Yes. So we just try doing that, or otherwise we throw a type error. But we don't throw it. We return it in the validation. And then we say like, okay, we expected a type representation D, which is typable, but we got actually this value instead. And that's like the entire type error thing. No line numbers, nothing. But I have also some tests to make sure that works actually. Like here. This is probably more like generic error, like sanity checks of Lisp. Type error. Expecting type non-empty. Actual type integer 2. What? What the fuck? Oh yeah, it's 2. I thought like I even get the wrong integer. But why is it a non-empty expression? What is this? What the fuck? Well, there you have it. I know nothing. Why though? Scope. Yeah, so what do you guys think about the amazing type errors? Scope type of structure expression. Not being exported, huh? There you have it. And it works! Hooray! Awesome. So, we now know for sure that it fails if you put in the wrong type into an if condition. If you put in a 2, it will evaluate as an error. It's a runtime error. And that's what we want, right? Like, we're not gonna do any truthy bullshit. We just want to have true and false. But what I do want to do is, for example, put in sub-expressions in here. So I want to be able to say is equal to 1, 1, right? That should be 0, 1, 0. That should be 0. Should be 0. So that should be, yeah, 0. Let's empty this and say integer 0. However, we haven't implemented equal yet, so let's do that now. Should be also pretty trivial to do. Just a basic, it's just a large lookup table. And for equality, we can probably also do far arc. Yeah, let's actually do the crappy equality first with no epsilons for float. So we'll just, yeah, we'll just do strong equality basically, like Lumi said. I think it's a good idea. But I realized I need to do this the same way as I've done text. So in the text binding, we basically first try to get out one value. Oh, we can't do that. So the idea I had with the, well, we want to make sure it's always the same, right? We don't do any cross equality. We're not gonna compare ints to doubles. That's insane. They always need to be the same. Yeah. So we're not gonna do this then. If we wanted to do this, we need to port it to a single type. That's not something we can do. We can actually, maybe a value implements eq, and we can just compare the values with each other. We can't. We need to evaluate it first, and then, yeah, like we need to evaluate the values first, and then we can just do it. So what happens if you evaluate something that doesn't, needs to be evaluated? We'll just say done. If you assemble, you will look it up, and if you don't do anything interesting, you're just done. Success. Let's do that then. Let's do evaluate, and then the result will just compare with equality on values. Yeah, that seems like the most lazy way of implementing this. Then we don't need to do any type juggling at all. So this is the library I'm using, right? And this thing just parses Lisp. I just want to know, yeah, it is equal. Okay, cool. We can use that then. Enclosure equals and identical. Basically 3 different notations of equality. Some of them have weaker than others. Well, I don't know what. Oh, maybe this is like Java equality then, like object. Maybe this is Java equality, I guess. I don't know what this is then. I just need to look it up. So I presume that enclosure, the single equality, is this one from eq. Type independent. What's the single one then? So equal is type independent equality. I thought maybe Lumby said something about it, but no. I'm on my own again. So yeah, generally I just want to like keep on the closure semantics as much as I can, because I'm already kind of stealing their syntax with this. So I might as well try and be consistent with them as well, as much as I can at least. And probably not at some point on some places. I know for a fact I'm not consistent with star. I'm not doing this. This is kind of weird in my eyes. Not for division, but it is for multiplication. And I presume it's because star is monoid, actually. Text, car, bool. There you go. So, what do I want to say? Like, now we finished doing evaluation of this branch, right? Like, we just proved that this works. I think we can actually first this as well. Equality thing. Yeah. Because I already have the primitive thing, right? I have already... What do I have? If you do something like this. Look at the primitives. And compare them to themselves. No, it's kind of dumb. What if we get 2? We get 2 primitives. And then, we compare them in one on the Haskell side. And on the other case, we compare them to... Well, if you do true, then they can have typing inequalities. Yeah, I don't know. Let's not do this. I think we're done with this stuff. We want to have an alias though, like Lummy suggested. So we have if conditions, we have comparisons. Now we want to add aliases. But this is just for the case, for example, with text. This should be called string because it's like the Lisp name. How do you do that? I mean, like, actually, I already have an alias system with functions. You can just say this. Like if you just, there you go. Right, we already have it in Haskell. So I guess we don't need to do that, because I'm not actually defining functions in lines. Not a variation between notions of equality across Lisp variants. In contrast, there are 5 equality notions. Lol equals egg equal p. Pointer equality, I guess. I don't know what most of these mean. But we already have equality, we're done. Hooray! Let's actually try this out. Stuff. See how it works. What is this? Alright, you need to die again. I probably it doesn't like to compile because I introduced quick check and always fails on quick check. For like libraries and stuff. Well, okay. I think this is pretty cool. What do you guys think? We have some bindings to Haskell functions, and we can execute Lisp code. Now, the next big step will actually be saving this stuff. Yeah, we're done with this. Like, I already have it in Haskell. What am I talking about? So the next step will be to do save the function. So this is a bunch of backend stuff actually. We need to save the Lisp code. And I also want to make a default, a company-wide default, I think. Or maybe we'll just make it normal defaults, actually. We'll just make defaults if nothing exists. We'll just jam in a string. Save the Lisp code per user. So we want to be able to modify it per user. And closure equality is pretty complicated, because data structures implementations are supposed to be transparent. So if I have two implementations of vector, the value should be equal, supposed to be transparent. The implementation of vector, the value should be equal to fully encapsulate. So you shouldn't be able to look into the implementation itself or something? Can you even provide different implementations of vectors like that? Data structure implementations are supposed to be transparent. I don't get it, because it's part of the language, right? The data structure. Like, you have that HCN stuff. And that's just, like, you know, defined. This is how we do maps. This is how we do lists. This is how we do vectors. I was under the impression this is just set in stone. And, you know, there are no rows trees in Closure. Well, there are if you know, build your own way of doing that with maps, I guess. You could do it with maps. But, like, there's no formal definition of rows trees, I guess. No work. And otherwise you say week minutes. See? It works. Let's give them some week minutes, I guess, to not be in the past. And, you know, now you worked for 22 minutes. Excellent. Give it a bit of a break. So you worked for 20 hours today. Good job, man. Good job, shoot. Oh, you need to be in English as well. Right, what am I doing? Excellent. Modify this again. We can test out the program. And still, you know, now it's showing the minutes. But what if we don't want minutes? What if we want, you know, hours? We can divide it, right? How about that? Now we have the hours. It's using integer division because this is an integer. If you make this a float, it will do the float. I should also make a round function then. But you know, it works. This is kind of what I wanted. So, you know, now we got like the hours, or the hours worked, and now we can multiply it. For example, if he's like earning 5 euros per hour, we can just add like multiplication. Ah, fuck. So we still need to do this. Week minutes, hours, divided by 60, and then times 5, and then close. So, yeah, he worked for 20 hours, and because he worked for 20 hours, if you multiply that by 5, you get about 100. Now we can make a text out of it as well. Text. You should also be able to round it actually. Should add a round function. But yeah, this is like wage calculations, right? We also should probably add like another constant, which is calculating based on user age or something, the minimum wage. But I'm not recording like their birthdays or anything, so we can't really do that easily. But this is fine for version 1, I think. We need to have rounding though, for sure. This is too ugly. Okay. We need to also get like if we, you know, mark up things and then lose focus, it should. Oh, it doesn't do that. Maybe I change that. I think I removed the evaluation of program away. Oh no, it still does. Right, okay, excellent. It's just a bit slow. We need to debounce the result, I think, as well. Too eager. I think it's like firing a lot of events. Oh, not that bad. Oh well. But it works! Let's add a round function then. See how we do it in round. That's cool. I don't want to do like nearest integer. I want to do up till so many points. Rounds up to decimal. That's good. That's a decimal, huh? This is like a library, I guess. I wanted to have it in base. No. Specified number of digits. Wow, that's beautiful. If you want to use instant calculation, you should use data decimal from decimal library. If you want to use format to number nicely, you should use text printf from standard library. But it's like using IO actually. The full shit. Okay, let's like make our own round then, I guess. I wonder if Closure has that. It's the same, I guess. Got the native int. Oh. So I need to like make a custom round then because I want to indicate the decimal places. No, we'll just do it to 2 decimal places. Like we'll make it like maybe we'll make like a currency or something. You know, euro. There you have it. Oh, you don't even want to know about numbers. Just real frac. Type default. 68. Oh, you don't know the value. What? No text. Defaulting the following constraints to type double. Oh, you wanna return from integral? C. Yeah, it could be double. Sure. Just do this, I guess. The second one. A to double. Double type variable A. Oh my god, this is so annoying. We'll just do like, I don't know, A to double. I'm upset. I think it's like an integer. Oh my god, there's still type defaults. No, I said it. From integral. Oh, it doesn't know what it goes into. It doesn't know what goes into the euro bind. It needs to also know that. But it's the same problem again. So like it doesn't know the result of this function because we, you know, might as well do. I thought you could just do double multiplication. Yes, you can. Well, let's do the other one as well. It's like, you know, the type application stuff. It just fills up the first argument in the function signature. So in this case, it will be the A. But if you have 2, like you have in from integral, and you just do the first one that occurs in that like list, and then the second one. The second one will be the return type in this case, I guess. So we can even see the thing. There you go. So first we do the A, which is like int, and then the second one should be a number, B, the double. That'll work. Like I figured it out so late. So useful to know. If you could do this. It's kind of nicer. Kind of nicer. Okay, let's make this safe. Also I want to copy over this code and try euro now in the real code. And I also want to test some Chromium because it's a bit faster. List. Significantly real faster. Yeah, now it's already done. That's the difference. Which did we do? We did shoot, right? Yeah. So he has some time to play with. Copy over this thing, and instead of text, we'll do euro. Euro. That's the problem. Why are you escaping? Are you showing? Oh, you're showing. That's the problem. Showing. So what do we need to do then? Currently, we're just displaying this entire thing. And because we're not showing, instead, if we're showing it like this, it will escape Unicode, I guess. The idea. But this is rounded correctly, right? That's fine. So I'm thinking of just like making a nice display for this for now. Let's do that first. And that's like, you know, ready to be shipped. And we can work on the backend stuff. I'm thinking of just making this entire field autosave. As soon as like it computes, like done, autosave. Then I don't need to make any buttons. Let's say we add it to Eurobind. Printing money. That's what you want to do, right? Printing money. That's what this module is about. Printing money. So let me think. Where was it? I think it was in roster. If this roster with you, but this is a bunch of shit. Side input, we don't care about that right now. I think I want to just move this to a new module. Yeah. So it's like the show employee module. I guess it can be put in roster because it's part of it, right? Roster, this is like show employee. Well, maybe we'll not do that actually. Like, I mean, maybe not put it into roster, but outside of it, because it's not set to do for that. Because like for that I need to also have a text area, and I'm not gonna make that. I'm gonna make that. Yeah, let's just show the success case first, and then figure out how to deal with errors later. We'll add a to do separate from eval so that decode can pretty print the form. Yeah, that's what I want to do later. I think it's not important right now. And the reason for that is because I don't even have the text area support at all. So yeah, it doesn't really make sense to work on that right now. Just make this work. Okay, so let's see. I have the X, right? This is the result. This is the run result, basically at the moment. And what we're doing is just displaying that run result. So what is the type of this thing? The type of this thing is Lisp errors or eval. Evalue. Yeah. It's like yeah, this thing, I guess. Oh, I'm actually using it right now. I've come to think of it. It's the first time I'm using it right. Because I fixed that right invariant stuff. So the result of this thing is the validation on empty Lisp errors, right? Lisp errors. And then we can have a value out as well. So I want to split that up on event validation, I guess. I have a function for that. Event validation. This gets an event and split the event up. So one will have the errors and the other one will have the results, right? Let's do that. Event validation. And we need to make the dynamic into events, and we can do that with updated. So now we have the result, which is like a tuple. You can better match on that, I guess. Error event. Well, think of it, I probably want to have two. It's later. Maybe I want to like separate this entirely into a Lisp input. Yes, that makes sense to me. And settings, Lisp env. Oh, you're building it there. Right. Work week, work month. Right, because we need to have both of those things to figure out the Lisp environment, which is in dynamic as well. Let's make a Lisp input. This function is too big. And actually put in those things. Work week. You know, figure it out. Minutes worked. The other one's also minutes worked. And then M as a result. There you go. I'm being attacked. Actually, I think, no, we're gonna put it in there, right? So, yeah, we're gonna put in the entire input. Actually do that. And then put this below here. Now it's like its own little thing. Yeah, keep those separated from each other. Like one thing I want to do is like, for example, hide this by default and like make it editable. Now we have the events, which is the first one is a text. If we have a result, so now we can try doing that actually that thing. So I guess the second one is the result, right? TD burn events. I could just simply display that with text event. Event message. Need to be a message as well. That's kind of annoying. Do you have any message just except a string? Can I? Oh, text event, huh? Okay, it's kind of dumb. So reflex DOM Haskell, right? You have this package flex DOM, and in here I have line text as well, I guess. But it's here. Line text. This is the thing I'm using to actually create those dynamic text. It wants to be dynamic. I can also make an event out of it by just giving it nothing in the first. Event text, huh? What that? Come on, that hold. What do you need? Post build just. Hold time. Dying. Tracks. There you go. That's horrible. Yeah, same thing, huh? So, like, we started, if there are no events at all, then we just show an empty string, and as soon as we get the first event, then, you know, we replace the text with whatever we got, and we keep on replacing it with whatever we're getting. Displaying that on screen. So, yeah. Hold out. On it, hold. That's kind of useful, I guess. Even though I never used it before. Probably not that useful at all. But now it's a function. There you go. We're gonna use it in this case though. Okay. Now it thinks everything is used in here as well. Thanks! So now we're displaying the events, like the result of the computation. But we're not displaying any errors. Because actually the widget already does it for us. We don't need to do that at all. Come to think of it. Why would I even do that? Yeah, why would I care? Widget already displays it. Let's try this. Let's try this. I'm still building. It is still building. Oh, chat. How's life? I got a job. It was nice. It's a pretty nice job. I'm gonna do sort of building work, I guess. It includes a car as well, which is really good situation. So that's nice. What's up with you guys? Didn't change? What? Excellent, it works! This is exactly what I wanted. And if you fuck up, you get a syntax error. So yeah, this is like all the things we need. So we get out the eventual result in euros by our own computation. And you know, if we paste it to someone with no work, it will say no work. We can do like arbitrary computations in here. Yeah, no work. It just keeps on displaying the same thing, I guess, because it doesn't update. Pardon me, pass, yeah. It's so hard to find anything in. Oh, deprecate, right, this is the old one. Schema, that's not how you're finding it, huh? Oh, it's like figuring it out, it's other stuff. Completely forgot all this stuff. A large stuff. I think it's like using the Postgres backend. It would be prudent to look for Postgres. Beam Postgres. Okay. Then quality. Oh, not like quality. From backend row. Default SQL data type. That's it. The CI. Case insensitive comparison. Oh, you have that now. I want this. I'm gonna make a note of this actually. So we have a to-do item for this. Well. And we can fix up some other to-do items as well with that. Yeah. That. Excellent. Okay, good we looked. We solved another problem. But so yeah, let's see, what is the default data type for this? We'll check. I think like the only thing we can do. I think it's by T, right? Yeah, PG by T. Okay. Int. Do you have? Do I need to like wrap it in a new type? I bet I need to do that. Int. Using generic or something? What is it? Be available. PG internal. I need to have a big one. What is it now? Or maybe it's a default implementation. That should be. That's probably it. I don't know. Not that one. World type. Oh, it's using PG has equality check. What does it mean? PG has equality check. It's fine, a macro. It's fine. Me tag the stack me. PG money. Case insensitive is nice. But what I want to have is like JSON. PG JSON. Beam SQL backend is string text. Okay. The Postgres JSON type. This stores textual values that represent JSON object. Library with an classical type which is JSON encode. Must be remember from JSON to JSON in order serialization to work expected. Default migration labels sets and functions are reassigned as type to field. I don't want to do to JSON though. It will be annoying and I don't really need that power. I just want to dump it as text. The problem is like I can't generate this as a table. Like that's what I've been searching for without explaining it. Choppy. Professional streamer. So yeah, like I want to have like a big ass field. And these fields are all small. I want to have a big one. Because our program maybe, well, like we could probably get away with small though. wait until it becomes a problem. I wouldn't expect them to make programs bigger than 255 characters, especially because I'm gonna make it annoying to use. The other thing we could do is just fix it up with SQL itself. I don't know what's like a good solution. Maybe we can actually change the type as well with like a migration stuff. I bet we can like alter tables. But then identity check will be annoying as well. So maybe I think it's time for a new type. You can just see how this thing is implemented. Yeah, PG by T type, right? Oh, we found them all. So yeah, PG data type syntax, scriptoid, small serial, big serial. We got a point, we got line, we got a box. Got it all. Variety factor. What does it even mean? This is like text. Is this what we want? Is this what we want? I thought it was, right? Text. Yes, we want to have text. Variable unlimited length. Okay, where's that used? Type text. PG text type. Oh, what's a nice way of search? Like, maybe use GitHub, I guess? Yeah. I tried. This is where we're gonna store the program. I'm just gonna attach it, and it's probably also maybe. Think of it. It's maybe big text. Yeah. It's nullable, like, at least. That's what it means. It can be null. It's fine. I'll just give you a default program, okay? Hold you 11. I don't like this way of doing migrations. Promise it eventually breaks after about 2 years. I guess it's like wearing out clothes or shoes. Hoping Nixos might change this, but I like this in Lisp. Type systems will produce music, so you could imagine. That's a beautiful quote. Postgres. Oh. But this is like in Beam Postgres. Like this is like the data they. Maybe it's from Postgres simple. Postgres. Everything is Postgres. Why did you prevent everything? Oh, here it is. Postgres. Big tech. PG text type. Oh, right. The magical thing we found somewhere, and now we lost it. Oh, it's here. Is it even exported? How about that? Probably not exported. We're just gonna copy it, you know? Yes, it's exported. Okay, nice. Excellent. No instance for show. That's your problem. Wait, this seems too easy. I bet it's lying to me. Let's upgrade. So yeah, that's the other thing we need to do. We need to make the current 11. And then we need to make like steps. Yeah. Make 11, huh? Right. So this needs to move from. Right. How annoying. Okay, we can delete this, I guess. We need to first move up 10 to 11. G. And then we need to move up 9 to 10. Because we're moving from version 10 to 11. That's the idea. Okay. We can delete this. That's the migration itself. You can just copy over these below contact info. Like most shit is gonna remain the same. That's the idea, at least. And because most shit is gonna remain the same, we can use this identity check everywhere. Make sure that everything is the same. That's what that does. But checks. So many fucking checks. We're gonna skip this song. Too much voices. Let's go type constructor plus version 11 raster db. Alright, we need to import it from the migration itself, right? We just made a new module. Do that as well. Yeah, and then finally the steps needs to be fixed. Everything is just pointing to current throughout the entire application except, oh no, not steps, but migration, right? This just wants it to be at current. And it isn't because we didn't do migration yet. We didn't hook it up. Beauty. Oh, it's 11, right? Right, credential needs to have another lens because we added. Why is it generating these? It gets confusing as well for a while. Like if you have a lot of fields, like I'm starting to get. Big text, but before the contact program. Program is too fake as well. You should name it to something proper, like wage. Oh. Wage program, wage clock, I don't know. From backend row. Undecidable instances to prevent this. No, I didn't do that, did I? Oh my god! Why? Illegal nested. Let's just not do that for entire backend thing then. I don't wanna do that. I'm upset. Oh, did I do it in the wrong one? Well, you suppose whatever. Once it has a SQL value text, syntax back arising from the use of. You don't know how to represent text. Is it like you're serious? You full of what the fuck? What has a SQL value text backend text? I know. Make it Postgres as well. This is Postgres, right? Yeah. You have it, right? Value. Oh, so needs value. Backend T. Just the fuck. Why do you go to that? I don't know. Not do this. Ah, there you go. Something like that. Excellent. Let's go type constructor value. We can try it though. Like I can just try it out, I guess. I'm not sure if it's that. Because actually got to think of it. Maybe I'll have a break. Yeah, I'll have a quick break. Be right back. I was thinking like before I start streaming, like, oh, I should have like a break after an hour, and then I completely forget about it. I completely forget about it. It's just like because I started getting busy with programming or whatever, and just get completely sucked into it. Nothing else exists anymore. Oh shit. Whoops. Don't hack me. Anyway, I'll have a quick break. So that's this one, and put on the break screen. Quick break. Okay. Okay, gamers, I'm back. I'm back. Let's see. Open up that again. Have some food. Ah. So let's see. Like I'm just thinking, how necessary is this? Probably not that necessary, but I don't know. I like to do things right. It will be just kind of annoying if you want to like write a little program in here, and then suddenly you go over that 255 character limit of default column wide. I'm not sure how much characters these are. I think like 30 or something. Well, let's actually, like, once we finish this migration, I think we're gonna end the stream. Yeah, waiting for compilation time. And we know it's gonna fail as well, it's like the annoying part. Needs to rebuild everything. Right, like the program actually significantly changed since we last played around with it. Normally I can like keep the backend running, but in this case I couldn't, because you know, it's backend stuff. What's development is front end. Yeah, exactly. You're expecting version 11, but you don't have to. Even if we update it right now, it wouldn't work because we didn't do it right. It would like confail on properties. So let's actually try adding that, making that right. We need to add a column. I think we did it here. Add column. Probably can use a default one though. Somewhere. Where I did it, maybe. There you go. Oh, credential. Actually, we just want to have this thing. I don't know. Maybe I'm modifying credential somewhere. Let's copy over that. Oh, here. It has some problems with that. Go. Credential. Credential 6 should be 11. 0011. And 5 should be 10. Add column. There you go. Credential. What do you have? Credential wage clock, huh? You can figure it out now. You should be able to figure it out now because of changes we made. Contact info. Right, that's annoying. This is something I still need to figure out. I need to juggle these foreign keys around, otherwise it doesn't work. And I've postponed it back then, and I'm gonna keep postponing that until, you know, until it actually like pays to fix this properly, which is probably never. Just a small, like, who cares about this module? This code is actually not even run into production, right? This is just some DevOps shit. Couldn't match type contact info T with company, credential company. Oh, right. Credential contact. You need to be credential contact. There you go. I can make the music louder now because I'm recording on a separate track anyway. Excellent. We'll see if that like plays well. We'll keep it like that for. The other thing is like in the near future I will be able to mix in other music, so I can like play proprietary music on stream, and it wouldn't matter at all. I can filter it out for the YouTube uploads. Great hacker, yuppie. Great hacker. Wait again. What am I waiting for? We are rebuilding everything. It should work now, actually. We can try running a migration, I guess. Let's make migrate. What does it even do? Grep, migrate. C, like 5. You do it from shell, huh? You can try that. So this should add a column to a credential, which will be used to store the program. Once we've done that, well, tomorrow I guess I'll just work on this off stream to actually integrate the saving of the program to that column and loading as well, I guess. Not that big of a deal. So, yeah, credential wage calc. This is what we want. Is text. Cool. So we did it. Hooray! Yeah, let's add all the shit. Integration shit. Yeah. Add a column for storing the program. Excellent. I think this is it. This is it. I'm gonna end it here. Thanks for watching, everyone. I think it was a pretty good stream. A bit like not a lot of people showed up, unfortunately, but that's fine. That's fine. We'll have slower days. You know, can't do anything about it. I think I had a lot of progress, so that's good. That's the most important part, at least like on these Friday and Sunday streams, right? Like I get a lot of progress to project, and I can maybe get financial independent. But anyway, I'm gonna leave. Thanks for watching, everyone. Have a good day. I'll see you guys tomorrow, because tomorrow we're gonna do some closure stuff again. We're gonna make a rock paper scissors board, and it's gonna involve a bit of game theory. It's gonna be fun.